Inverse variation, it says it on the worksheet, but direct and inverse variation. Okay, when two things vary directly, that means when one of them goes up, the other one kind of goes up with it. For example, what would be a good example? Like the more hours you work at your job, the more you'll get paid, right? That would be direct variation. What else? There's a lot of things. Maybe the more you study for the test, the better your grade is. So when one thing goes up, the other goes up. Or when one thing goes down, the other goes down with it. So when there's a direct relationship, they're kind of tied together. So with the job one, like let's say you made like $8 an hour. You guys are probably too young to work. Does anybody have a job yet? Where do you guys work at? Where do you work?
It's a seasonal job. I work at a pumpkin patch.
Okay.
What do you? $8 an hour.
$8 an hour. So your pay equals $8 per hour. Shh. Your payment is equal to $8 an hour. This is what a direct variation relationship looks like. As your hours go up, your pay goes up. Or shh, if your hours go down, your pay will go down. This number right here, the $8 an hour thing, the 8 is called the constant of variation. It just kind of tells you the number that links those two variables together. So if you worked 4 hours, he would get paid 8 times 4, $32 for 4 hours of work. If you worked 6 hours, you get 48. 8 times 6. Anyways, so it can look like that. But you could also manipulate this formula a little bit. Like if I divided by h, for example, I would get P over H equals 8. So payment divided by hours should equal 8. So usually it's written like this. Sometimes it looks like that, but that's direct variation. Okay, so if that's what direct variation means, what do you guys think inverse variation means? It means if one of the variables goes up, the other one goes down. If one thing goes up, the other goes down. Can you guys think of an example? It's kind of hard, but...
This is kind of an interesting one, but if you pull like the string on a blind down, the blind goes up.
Yeah, it's that kind of idea. The more you pull the blind down, inflation.
The more money you pump into the economy, the less value it has.
The value of your money is less, yeah. That's true, that's a good example. I got one, I always use this one. The faster you drive, the shorter the time is to get there, right? The faster you drive, the shorter the time is to get there. So inverse variation, probably more. If I use that, I'll just make it up. Inverse variation usually looks something like this. Unlike the last one, the variables were both on the top. Like you could think of this as over 1. But the variables are in the numerator. But on this one, one of the variables is in the denominator. This is the constant of variation. Constant is just kind of a fancy way of saying a number. That we know what it is. It's constant because it's always worth 5. Variables just means letters. But you can manipulate this one too. Like if we multiplied both sides by y, what would this turn into? It'd be xy equals 5. Okay, so inverse relationships could look like that too. Maybe I don't know where I'm gonna put that. We can. So I'll write over here. For direct, could look like where k is the constant, or it could look like a over b equals k. K is the number. Inverse could look like a equals k over b, or could look like ab equals k.
So would 5 be direct?
Alright.
Negative 5x plus y equals 0.
So on number 1, should have another. Okay, so we're just supposed to say direct or inverse. So on number 1, it's x times y equals 15. Xy equals a constant. So would that be a direct or inverse relationship? Yeah, that's almost the last example I did. Yeah, that's an inverse. So you just write inverse for that.
So when direct, to make that direct, it would be x times, would it be 5x equals y?
Well, there's a couple ways. It could be x equals 5y, or it could be x over y equals 5.
Okay.
That would be correct. They look pretty similar, so it can be confusing. Anyway, number 3, y equals 13/12, 13 over 12x. What do you guys think that one would be? That's basically the same thing as y equals 13/12 times 1 over x. Okay, so basically this is the constant, kind of like the 5, but the variable over here is on the bottom. So it's actually more like this one.
Inverse.
Yeah, if the variable's on the bottom, that's like an inverse relationship there. Number 5. Oh, I wrote this one weird. Well, okay, if we added the 5x over to the right side, what would that become? Let's think of it that way. If we add the 5x to both sides, what will the equation become?
Y equals 5x.
Okay, y equals 5x. Is that more like a direct or an inverse? Direct. That was kind of like our first example, like getting paid per hour. So it's direct. Okay, number 7, these is kind of easy. Find the constant of variation. The constant is basically the number. It kind of tells you, like on 7, that's a direct relationship. So as y goes up, as x goes up, y is going to go up. But y is actually going to go up 3 times faster because of that 3. So the 3 kind of tells you how fast it goes. But the constant of variation is 3. That's all you have to write.
Just 3.
Yes. Number 9, what's the constant of variation? 5. Number 11, 3/5.
So like on number 10, you just say 9 by itself, or?
No, it's
Say
not.
1, because you don't know what 9 is. 9 is still a variable.
9's not a variable, but what do you guys think on number 10?
1/9.
It's like 1/9. Okay, 13. Now we haven't really talked about these yet. This is most of the problems with direct inverse are like this right here. Okay. When two things vary directly, the relationship is explain this easily. So you remember at the beginning it was like, what was it? Pay equals 8 times hours. So, and then I solved, or divided by h, so pay over h equals 8. So no matter what payment an hour you have, they should equal 8. Okay, so anyway, that's not helping. The way you set it up on these problems, it'll just be a over b equals a over b. When things vary directly, their ratios will always be equal. Okay, they should always equal the constant variation, but we're just going to set them up like this for directly. If they vary inversely, it's just a times b equals a times b. So what they're going to do is say, if a equals 8 when b equals 3, then what does a equal when b is 4? Or something like that. And we'll use our cross multiply trick on this one. Or if they vary inversely, they'll say when a is 8 and b is 3, what does a equal when b is 4? And we'll just plug those numbers in that they give us and solve the equation. Okay, so we got varies directly, varies inversely. Probably too big. All right, so on number 13, it says y varies directly as x. Okay, so that means we're going to be using this, varies directly. Instead of a and b, they're using x and y though. So you could do x over y equals x over y, or you could use y over x equals y over x. Doesn't really matter. So if it says y equals 6 when x is 15, y is 6 when x is 15, that should be equal to find y when x is 2. Now, how did I know to put y on the top right there? Okay, it's because I put y on the top over here. They said when y is 6, x is 15. So then they said find y if x is 2. So if I put y on the top over here, I got to put y on the top over here. You guys remember how we solved these? It's been a couple chapters. Cross multiply. 15 times y equals 6 times 2. So how do I solve this for y? Divide by 15. Okay, is that going to work out well? Well, it's going to be a fraction. 12/15 does not divide well, but it does reduce.
4/5.
If you divide by 3, yeah, it's 4/5. Or if you put 0.8, that's okay. The book or the worksheet put 4/5. Okay, number 15 says varies directly, so we're going to do the same thing. The first two are directly, the next two are inversely. Somebody want to try set 15 up? You don't have to solve it, just how would we set it up? Okay, Moses?
5 over 4 is equal to x over 8.
Okay, 5 over 4. Now,
Y.
yeah, if you put 5 on top, since it's the y, you would need to put y on top.
Yeah.
Okay, and then cross multiply. So 4y equals 40. This one will come out nice. So y is okay, number 17 17, varies inversely. How did I say varies inversely sets up?
A, B equals A, B.
Yeah, it's just A times B equals A times B. Maybe a little bit easier. So, or X times Y equals X times Y, I guess. So in number 17, it's Y is 9 when X is 10. So that'll be our X times Y. And that should equal, find Y when X is 5. So X is 5, and we don't know that Y. So 9 times 10 is 90. Divided by 5. What was that? 18. Okay, so somebody help me set up 19. 19 also varies inversely. Luke.
3 times 21 equals 9y.
Okay, yep, 3 times 21 equals 9 times y. So that would be 63 equals 9y. 63 divided by 9 is... Okay, 21 says it's back to varies directly. So this would be the A over B equals A over B, or X over Y equals X over Y. So Y equals 10 when X is 20. Find Y when X is 3. It's like it'll be another fraction. So 20 times Y, 20Y, equals 10 times 3, 30. So to solve for Y, we're going to divide by 20. What's 30 over 20 reduced to?
3 halves.
Yeah. If you divide by 10, it just reduces to 3 halves. That's it.